Here we have another application from the National Archives and Record Administration. It's sort of related. It's government data. It's a rather broader set of government data. So here I say the parallelism is over item. In general, I use the word item to represent the thing that is stored within the data. And here we have government items. Some of those government items are associated with people, some with government units, and so on. And so this needs to has the same type of uh, processing as we saw before, MR search and query indexing. It also adds PP, pleasingly parallel, because if you look at what the approach is, there's a whole set of things: physical and legal custody of the data, pre-processing the data for viruses, identifying formats, in doing indices, categorizing the records as to their privacy status, transferring formats to different formats, and all of those, actually, except the indexing, are done independently. So that's why it's so-called pleasingly parallel. A bunch of operations which run on um, all the items in the data set independently. And then, of course, we have to search and retrieve this data set to particular requests, both by sort of official users and public users. And here we have hundreds of terabytes of data. They're running on commercial databases with obviously a bunch of support software and specialized search products. And as this moves forward, you will find these use cases have typically three sections: application, current approach, and futures. Um, the futures of use case one don't exist for 75 years. In this case, we have a future in the near future, and here they're pointing out that there are a lot of distributed data sources because every agency has its own data, and somehow they need to be logically centralized. And you probably don't want to make it actually centralized in the same place because that's pretty inefficient. A lot of data transfer. Rather, you're likely to have a distributed storage with each agency maybe making a different choices to the cloud they're using and so on. And so we need to federate the clouds and avoid actually transferring the data, but just leave it where it is and take logical custody of that information. So here we have some comments on the classification. I already pointed out the pleasingly parallel classification, which in a MapReduce framework is called the map-only example. And that's actually, it should miss out item 4. It should just be 1 through 3 and 5 in the current approach. And because item 4 was making the index, which is not pleasingly parallel. Some parts of it are, but the overall making of index has some global issues attached to it for obvious reasons. So it's actually typically not, it would not be called pleasingly parallel. However, taking each data set and making certain they are using a modern format is pleasingly parallel because you do not need to integrate across the data sets. You just need to do the same thing for every item in the data. So here, I just listed people, though they're actually similar to the use case one, items. So here I said government items, and if we go on to the general discussion in the next unit, we will discuss very common items like images, health, electronic medical records, books, web pages, sequences, scientific observation, etc. And for this particular use case, items are government data. Here we do have parallelism actually with the people viewing the data. For use case one, we don't because of the 75-year rule. It's the only people viewing it certified government people allowed to do that. We don't have the public viewing. But for other data, almost all other data, anybody, with some restrictions, lots of people can view it. So here we have a couple of related use cases, one being the current example, and the next being some future example. And they each actually are using a new idea, namely the use of recommender engines, which is indicated at the bottom by collaborative filtering up here, which we'll discuss on the next slide. And the idea here is that surveys, as anybody who writes surveys knows, are very flaky, and that most people don't bother. We get so much email. When we get the sweet email saying, please spend 15 minutes telling me how you're doing, we know it will actually take 2 hours, and we never respond to the email, the survey request. Anyway, we don't gain anything. It's very rarely do you gain anything significant from answering a survey. So it's pretty hard to get people to respond to surveys. And so effectively, the idea here is to fill in the gaps using recommender systems. That's how Netflix and Amazon decide what you want. You don't fill in the survey saying what you want. They take a look at you, find out who you like, see what there's other people who've done in the world, and use that to suggest what your answer is. And so it's a rather interesting technique. And here they have around a petabyte of data. It's streamed, which is a characteristic that we will learn more about. But it's only streamed in a sort of specialized times, like while the census is happening. So we don't actually put it down as a streaming category. That's a little different from some of the other use cases where streaming is continuous. There's obviously important security constraints, confidentiality and secure, it says, and there has to be properly provenance, namely everything must be auditable to see that the right processes have been done, because that's what the law says. The data quality should be very high, bad data should be removed, and tests should be performed to look for accuracy and reliability. And they use actually a pretty interesting collection of modern technologies of Hadoop and Spark, which are traditional and iterative MapReduce, Hive, which is the SQL interface on top of NoSQL databases, R, which is a big statistics package, SAS, a commercial statistic package, Mahout, which is a machine learning library. I don't actually know what Allegrograph is. MySQL is a well-known database, as is Oracle. Storm is for streaming data. Big Memory is important in-memory technology to make cloud applications run faster. Cassandra is a NoSQL database, and Pig is a high-level piece of software built on top of MapReduce to allow you to code MapReduce applications faster. And so here they point out from the future is there is a lot of need for sophisticated analytics to be developed to improve survey responses by filling in the gaps. And then you have to find out how good all that stuff is. And so here we have our discussion of new ideas which were introduced there. And the one that I highlighted here is collaborative filtering, which is a key algorithm behind recommender systems, and they're used to estimate values of nearby points. And it's sort of a very generalized, sophisticated interpolation or extrapolation method, which is not it's not quite the same as traditional methods, because there's so much missing data in these types of applications. You can't use the traditional averaging techniques which you learn about for interpolation in your elementary textbook. So here we are. We come to the variant of this, which is same basic idea actually of using collaborative filtering, but it involves new types of data, because the world is full of new types of data from the web, from smartphones and things like that. And so the opportunity, and then we can do web scrape data, electronic transactions, social media, geolocation, and we can get all that information and we need to do the same types of things that we did before with the same type of software stack. So this is sophisticated new software to do surveys, where those surveys are going to probably be even more difficult to interpret because they're done using non-traditional data. And that particular use case introduced no new classification, so there was no follow-on slide for that. Thank you very much.